To the organic chemistry playlist. We have a problem here, and basically what this problem is getting at is it's telling you, okay, so we have this molecular formula which could have many isomers, right? But we are specifically asked in this case to propose a structure that would give one H-NMR signal. So the goal is one H-NMR peak. And we'll just draw P because I'm too lazy to write it out as the full thing. So that's the goal. Now, how do you approach a problem like this? Because this can get kind of tricky, right? You're probably thinking of structures in your head. Well, let's first calculate if we have any double bonds or rings by calculating the degree of unsaturation. Remember that that is 2 times the number of carbons, so that's a total of 10 there. We add 2 to that value. We subtract the amount of hydrogens, the number of nitrogens, in this case we have 0, and the number of halogens. So this is 12 minus 12, so that equalizes to 2. Remember, this is all over 2. Equalizes to 0 over 2. And that in turn tells us is there are 0 degrees of unsaturation. So there's no rings here that we have to worry about, which is good to know. So that might help you deduce things. And in this case, when you have all these random structures you might be able to draw, think about in your head. Try to imagine a structure and just think of something that could give you a symmetrical molecule to the point where you only get one H-NMR signal. And honestly, just plugging and chugging a bunch of different structures in your head will work fine here. When I was initially working out this problem before I made this video, I came across this structure, which works just fine. So if we have a central carbon, and we were to come out in 4 ways, like this, and we put a chlorine on the end of all of them, if we put a chlorine on all of them, notice that we have a little 4-way symmetry going on here. So this half of the molecule is equal to this half, and then if we were to look at this plane of symmetry, this half is equal to this half. So all these environments are relatively equal. This is a symmetrical molecule. And now we just need to make sure that we satisfy the number of hydrogens that we have. So we have a carbon here, a carbon here, a carbon here, a carbon here, a carbon there. And notice that we have 2 hydrogens here, 2 hydrogens here, 2 here, and 2 right in here. And because all of these, all the hydrogens relative to each other are homotopic, this will give rise to one signal. So that there is the solution to that problem. I hope you guys enjoyed.